This you learned in grade 9, exponent laws. When you are multiplying powers with the same base. Remember this from grade 9? Can someone give me an example of two powers that have the same base that you would multiply together? Any example? Yep.
5 to the power of 2 times 5.
Okay, I'm going to use an x to the power of 3 because that we can actually solve. X to the power of 3 times x to the power of, okay? When you're multiplying powers, see how these have the same base? What's the base of this power? X. So if the bases are the same, this rule only applies when it has the same base. What do you do with the exponents? Add. Okay? When dividing powers with the same base. Can someone give me an example of two powers that have the same base that you would divide? Okay, good. X to the power of 5 divided by x to the power of 3 equals, what do we do with the exponents? Subtract, good. So this one would be equal to x to the power of 2. And I should have simplified this one. This would be x to the power of 5. A power of a power. Who remembers what that means? Who can give me an example of a power of a power? So you would say that as x to the power of 2 to the power of 3. What that means is this is the base. So all of this is being repeated 3 times. So I'm going to show you why this works. So we have x to the power of 2. How many times am I going to write the base? All of this is being written 3 times. So x to the power of 2 times x to the power of 2 times x to the power of 2. A power of a power, you're actually multiplying by itself, right? So now what? What do I do with the exponents? It's multiplication. What do I do when I'm multiplying powers with the same base? What do I do with the exponents? Yep. Well, right now, just for this example, what am I doing? X to the power of 2 times x to the power of 2 times x to the power of 2 is x to the power of 6, right? So we don't have to actually write all of this out. What do we do when we have a power of a power? What do we do with the exponents? Multiply. I just wanted to show you why we multiply, because you're writing the base 3 times. So if the power has, if it's a power of a power, 2 plus 2 plus 2 equals 6. That's the same as saying 2 times 3 is equal to 6, right? Okay, when a non-zero base, so anything but 0, has an exponent of 0, what will the result always be, Nathaniel? 1. And let's give an example. So give me any number that's not 0. Any number. 8 to the power of 0 will always equal 1. Do you understand why that works? So any non-zero base, so give me a number between 1 and 10. 5, sure. Raised to a negative exponent, so let's say to the power of negative 3, okay? The result is always going to be what? The reciprocal of the base. And I'm going to explain to you why this works, okay? Why is it the reciprocal of the base? Raised to the, so if it's a negative 3, it becomes positive 3. So we'll say to the opposite exponent. So what's the reciprocal of 5? 5 is a whole number. We can always put 5 over, we can always put a whole number over 1. It doesn't change it. So what's the reciprocal of 5? 1 over 5. No, it's positive. It's raised to the opposite exponent. So the exponent was negative, it becomes positive to the power of 3. Okay? Okay, so we're trying to figure out why these rules actually work. So we're going to visualize it. So the first one I'll do with you. X to the power of 3 would be x times x times x divided by x to the power of 1. So I just write x once. You subtract. So it would be x to the power of 3 take away 1, which is x to the power of 2. And this is why this works. What's x divided by x? X divided by x cancels out, right? It becomes 1. So I'm left with x to the power of 2. I'm just trying to visually show you how this works. And when we get to the bottom, you're going to see why the negative exponent rule works, okay? So do all of these. X to the power of 3 divided by x to the power of 2. X to the power of 3 divided by x to the power of 2 becomes just x, because we're doing 3 take away 2, which is 1. So you could just write x. Okay, what about the next one? It's 3, x to the power of 3 divided by x to the power of 3. When you're dividing powers with the same base, you subtract. And look what happens here. They all cancel out. So it's x to the power of 0, which is 1. Exactly. I can multiply this by 1. I can multiply all of these by 1. It does not change anything, right? See how I multiplied everything by 1 just to show you? So the answer to this is just 1 divided by 1, which is 1. Do you understand why that works? Okay, what about the next one? X to the power of 3 divided by x to the power of 4. I'm going to write it out here. When we divide powers with the same base, what do we do with the exponents? Subtract. So I'm doing 3 take away 4. What's 3 take away 4? Negative 1. But how would we write that? Well, let's look here. This cancels out, cancels out, cancels out. What am I left with? 1 over n. Remember the rule? When we have any power that has a negative exponent, we write the reciprocal of the base. So what is the reciprocal of x over 1? 1 over x, right? To the power of, we make the exponent positive, to the power of 1. And there's the answer right there, 1 over x. Do you see why that worked? Make sense? Okay, the next one. X divided by x, x divided by x, x divided by x. Well, let's calculate it. X to the power of 3 divided by x to the power of 5. What do we do with the exponents? 3 take away 5. What's 3 take away 5? Negative 2. So the answer is 1 over x to the power of 2. Right? 1 over x times x is 1 over x squared. Do you understand? And I can put all of this in brackets to the power of 2, because if I expand that, I can put another 1 here. I can multiply it by 1. 1 over x squared means 1 over x times 1 over x. It's all of it to the power of 2. It's not just the x to the power of 2. It's also the 1 to the power of 2. Does that make sense? Yeah. Okay, the next one. X to the power of 3 divided by x to the power of 6 is x to the power of 3 take away 6. What's 3 take away 6? Negative 3. And let's check. Cancel out, cancel out, cancel out. And what am I left with? 1 over what? X to the power of, how many x's are there? And look at the exponent. 3. Negative 3 becomes positive 3. And we've just done a reciprocal of the base. Does that make sense? That's why that's the rule. Reciprocal of the base, and then it's raised to a positive exponent. So we write the reciprocal of the base. Yep. Sagita, what's the reciprocal of x? 1 over x. And the positive n becomes, the negative n becomes positive n. That's it. That's the answer for that. Okay, so try the rest of the examples for number 3, and we'll take them up in a few minutes. The reciprocal of the base. Well, the base is 6. What's the reciprocal of 6? 1 over 6, and all of that to the power of, so simplify it. What's 1 over 6 times 1 over 6? 1 over 6 times 1 over 6, multiplying fractions. You multiply numerator times numerator, denominator times denominator. The answer is 1 over 36. What? Okay, so it has a negative exponent. Look here. So the first step is to write the reciprocal of the base. What's the reciprocal of negative 5 over 1? 1 over negative 5, right? That's the reciprocal of the base to the power of 1. So the answer is just 1 over negative 5. That's it. Yep. You can write it as 1 divided by 6 to the power of negative 2. So what is 6 to the power of negative 2? So it's 1 divided by 1 over 6 to the power of 2, right? How would you simplify that? 1 divided by 1 over 36. How do you divide fractions? You can put this over 1. How do you divide fractions? No. This would be 1 times 36 equals 36. Dividing fractions, you multiply by the reciprocal. Remember that? Okay, try the next one. Because we are multiplying powers with the same base, we do what with the exponents? Liza? Add. Right? When you're multiplying powers with the same base, you add the exponents. What is negative 6 plus 4? Negative 2. So I've turned this into a single power, but now we have to simplify it. What is 3 to the power of negative 2? It has a negative exponent, so I write the reciprocal of the base. What's the reciprocal of 3? What's the reciprocal of 3? 1 over 3, and I put all of it to the power of positive 2. So again, what this means is 1 over 3 times 1 over 3. I'm writing the base twice. So it's everything to the power of 2. It's 1 to the power of 2, right? 1 times 1 is 1. 3 times 3 is, the answer is 1 over 9. You do not have to show all these steps. I'm just trying to break it down for you. Raise your hand if you got 1 over 9 for this one. So we're dividing powers with the same base, so you subtracted the exponents. So 3 take away negative 1. What's the answer? 7 to the power of 4. And if we simplify that, 2,401. Raise your hand if you got that one. That one was easy. Good. So reciprocal of the base would be 1 over 2 to the power of 5. And it's not 2 times 5. It's 2 to the power of 5, right? Because it's 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2. We're writing the base 5 times, so it becomes 1 over. Good. That one was easy. Dividing powers with the same base, we do what with the exponents? We subtract. Yep. What's 4 take away negative 3? What's 2 to the power of 7? Good. You turn these these powers into, okay, so it's 1 over 2.
1 over 2 bracket to power 1.
Yep.
And plus 1 over 4 bracket to power 2.
Okay.
And then I got...
Excellent. So you did 1 over 2 plus 1 over 16. So you simplified that.
And then
Good.
I wanted to multiply 1 over 2 by 8.
Good. Common denominator. Multiply by 8. That becomes
8 over 16 plus 1 over
perfect
16.
equals
9 over 16.
good. Okay, and then the last one, I. 3 to the power of negative 1 plus 3 to the power of negative 2. What do we do here? We have negative exponents. Yep. Same thing. 3 to the power of negative 1 becomes 1 over 3 to the power of 1. I don't need to put to the power of 1. Plus 1 over 3 to the power of, what's 1 over 3 to the power of 2? Okay, but then we need a common denominator because you're adding fractions. What's the common denominator? Multiply by 3. And we get 3 over 9 plus 1 over 9 equals 4 over 9.